Okay, so week 11, lesson 1, our topic is compressions and stretches of functions. You can find this in chapter 10.5 in your textbook. Okay, we've talked about this before with many different kinds of functions. So a lot of the stuff in this chapter are not new. There is one or two new things, but most of it is stuff we've talked about. And just the notation of it is a little bit different. So if you look at this, it says g of x equals -1 times f of x. So what we're going to do is we're going to take our function f of x and we're going to multiply it by -1, and that will give us the reflection. Okay, so in this case, you see on the left-hand side, we have a parabola. Our apparent function is this f of x equals x squared, which is the blue parabola. And what they did to get to the red is they took x squared and they multiplied it by -1, which gave us negative x squared, which made it reflect over the x-axis. Okay, the one on the right is the cube root function, again in blue. It kind of makes like a curvy S type of shape. And by reflecting that over the x-axis, we multiply the cube root of x by -1, and we get negative cube root of x. So if you notice, this high point that's on the right, the high line flipped over the x-axis is now at the bottom. And the low line that was on the left-hand side flips up and is now on the top of the graph. Okay, now sometimes you could also do the opposite. So for example, if I gave you f of x equals -x, and I wanted you to reflect that over the x-axis, you would do -x times -1, which would give me f of x equals +x. Okay, so whatever the sign is, the sign flips to the other sign, and that's how you get to reflect up and down over the x-axis. All right, vertical stretches. So if you remember we talked about in class, this is like silly putty. So if you were to take a graph and you were to stretch it up and down, it would get taller and skinnier. Okay. In this case, we take our function f of x and we're going to multiply it by a value k. Now, underneath this, you see it says the absolute value of k is greater than 1. And the reason why they do the absolute value of k is we don't care about the positive and negative signs. The positive and the negative signs determine reflection, not vertical stretches. Okay, so just look at the number, not the sign of k. And it has to be greater than 1 in order to be a vertical stretch. So in our first example, we have f of x equals x squared. And you can see to get to g of x, the only difference is they multiply g of x by 2. So if we're looking at our graph, the blue is our original. And it looks like they took that red graph and they stretched it up and down a little bit. So now it's taller and skinnier by 2. Same thing with our cube root function. This time, if you look at this, they multiplied it by 4. So it's 4 times taller and skinnier. So I kind of imagine either a silly putty or if you had the graph on strings and you were to pull the strings up and down, it would get taller and skinnier. All right, vertical compressions we've also talked about. So again, we're going to multiply our function by a value of k, but this time our k value, the absolute value of that has to be between 0 and 1. So this could be shown as decimals, it can be shown as fractions. As long as the value of the fraction is between 0 and 1, it will be a vertical compression. Remember, compressions kind of are like you're smushing your graph. So if I were to take my hands and put them above and below my graph and push my hands together, it would make the graph be shorter and wider than the original. Okay, our left graph is the absolute value of x plus 1, and we can see that they multiplied it by 1/2. 1/2 is between 0 and 1. So if you see, the red one is half as tall as the original. Our parabola on the right, again, they multiply by 1/2. So the second one is much shorter and wider. Okay, it's not always 1/2. It could be 3/4, 1/8, 1/8. It could be 0.75, as long as the value is between 0 and 1. Okay, this is the new part. We've never talked about horizontal stretches and compressions before. Okay, so horizontal ones, if you look at the formula here, it says f, and then it has k inside the parentheses with the x. So the location of k is a little bit different. Instead of multiplying the entire function by k, you're going to multiply just the x by k, okay? And it's all about the location. It's inside with the x, Okay. Now, stretches and compressions, when you're talking horizontal, it's the opposite of what you think it is, just like it has been for all of our other topics. So normally when we talk about stretches, we want K to be greater than 1. But in horizontal stretches, we want it to be between 0 and 1. Okay, so looking at this one, you can tell they multiply by 1/2, but notice how 1/2 is inside the parentheses with the X. In our last example, 1/2 was on the outside, and that is the big difference. Horizontal's inside, vertical would be outside. Same thing with compressions. So again, we're multiplying our X value by our K, and this time it's the opposite of what you think. Compress usually think small. We want our K value to be the opposite. We want to be greater than 1. So if you look at our first example on the left, we have X plus 1 squared. So what they did was they multiplied the X by 2. So that made it 2 times skinnier. If you notice, it moved on the the X-axis versus the Y. All right, on the other one, we have absolute value function. Sorry, I can't talk today. And again, they multiplied the X value by 2, and that made it compress. So remember, you're compressing on horizontally. So it's being smushed from left to right versus up and down like we were before. So that's why these ones look a little bit taller and skinnier because they've been compressed horizontally from left to right. Okay, I did not do any of the triads for this one because all of the triads that were in the book could have had multiple answers. They just wanted you to write some of the equations that could have represented the different kinds of functions. If you would like to try them, and then you can send them to me and I can check it for you. But if not, you can try the classwork on page 441, numbers 3, and then 5 through 9. This one's a really quick one. The exit ticket is page 442, number 15 and 16. Please make sure that you submit those for feedback. They are available up on Schoology, or you can email them to me or send them to me through the drive. But that is what I am providing feedback on and what is being recorded in the gradebook. If you have any questions, come check me out and Blackboard Collaborate.